Hello friends. For the last 6 months or so, our analysis in this channel was essentially revolved around on the topic of international trade, finance as well as international business. Today onwards, we are launching a new segment in our channel called Mathematical Tools. Of course, we will continue our discussion on international trade as well as business. But the reasons behind choosing mathematical tools as a separate segment in our channel is that the use of mathematics in social science, especially in economics as commerce, has expanded phenomenally. So our humble attempt in this particular segment will be to introduce some of the popular mathematical tools that are extensively used in the analysis of economics and commerce in particular and social science in general. And today we are starting our segment with the concept of the set theory. Welcome to the session. Let us start our discussion with the meaning of set. What is set? Essentially, set means a collection of definite and well distinguished objects. What is set? Set is nothing but a collection. Collection of what? Collection of objects. These objects can be anything. So by definition, set means a collection of definite and well distinguished objects. These objects can be anything, as we said. It can be numbers, it can be alphabets, or it can be anything. So set means a collection of definite and well distinguished objects. Even though in our analysis we will be focusing on mostly numbers and along with some kind of alphabets as well. Now, how to write set? There are two ways of writing a set. There are two ways. How to write a set? There are two ways. One way is known as enumeration. One way is known as enumeration. The other one is known as description. So these are the two popular ways of writing a set. How to write a set? We have two methods available. One is enumeration and the other one is description. Now let us explore what is the difference between these two methods of writing a set, because these two methods are needed for the analysis of set theory, and when we explore the types of set, the set operation as well as all these two methods should be familiar to you. Now let us start with the most popular method, which is the enumeration method. In enumeration method, as the name itself suggests, in enumeration, we will list out each and every element of a set. So when we write a set, using the method of enumeration, we will present, or we will enumerate, or we will numerically present, or we will present all the elements in the set. Now let us just put me an example like here. For example, let me put a set like this. Set S equals, in brackets say 2, 3, 4. This is the method of enumeration. See here certain features. One, the name of the set is usually presented as capital letters of English alphabet, and I put it S here. S equals, then two brackets, a starting bracket and ending bracket, because it is customary to use a pair of braces or brackets when you present set, either in the form of enumeration or in the form of description. You have to present, or you have to include set in, or you have to incorporate set in bracket. So we have bracket here and the members of the set 2, 3 and 4, and the members are separated by commas. So in the method of enumeration, we will present, or we will list out, we will enumerate each and every member of a set. And of course, we will incorporate them in bracket. So this is the method of enumeration. It is very simple because it's very easy to understand. Because by looking at this set, you can see that there are 3 elements in the set, 2, 3, 4. And the members in the sets are called the elements of a set. For example, let me put like this. As far as this set is concerned, we have, say, 2 is an element of set S. This symbol 2 is an element of set S, 3 is an element of set S, 4 is an element of set S. At the same time, 6 is not an element of set S. See, element is represented by this symbol. So, 2 is an element of set S, 3 is an element of set S, 4 is an element of set S, 6 is not an element because 6 is not here. That's a method of enumeration. It's very simple to present and it's very easy to understand as well. So that's a popular method. But even though it's a very simple method, you may not be in a position to follow the method of enumeration always. For example, if I am asked to write a set using the method of enumeration of all the students of my college, I may not be able to write it because it may not be impossible, but it may be improbable. You may not be able to write all the students of my college in one set. It's very difficult. If I am asked to write a set by using enumeration of all positive integers, how can I write using enumeration? It will be impossible. So there are certain methods available, or in fact we have an alternative method available of writing a set using description, which is the second method. So second method is using the description. As the name itself implies, description means you are describing the elements of the set rather than writing each and every element of a set. So in the method of description, we will describe the features that element of that set possesses. In the method of description, we will list out, we will explain, we will elaborate the characteristic of the elements of the set that possess. We call it the method of description. Let me elaborate it. For example, say, let me write a set of all positive integers. As I said, I cannot be or I will not be able to write by following the method of enumeration. So I am using the alternative method of writing a set, which is description. And let me put like this. For example, let me put the name as I. So it's I implies integers, so capital letter should be there as a title of the set, as a name of the set. I in bracket x / x is a positive integer. What is this? In the method of description, I put like this. This is read as like this. I is a set of all x such that x is a positive integer. So, we explain the characteristic of that element of a set in the method of description. So, I is a set of all x such that x is a positive integer. If I am asked to write a set on all students of this college, I will write like this. For example, say, let me call it as G. G is a set of all x such that x is a student of this college. So, I am not writing each and every element of a set, but rather we are explaining, we are presenting the characteristic, the feature that the element of those set possess. So these are the two alternative ways of writing a set. So we have the method of enumeration and we have the method of description, and we also saw what is the meaning of set as well. Now, having understood the concept of set, the method of writing of a set, the members of the sets are called element, as we have already said. Now, we will proceed our analysis to explore different kinds or different types of set. Now, let us explore different kinds or the types of a set. Okay, we have different kinds or type of a set like universal set, null set, finite set. infinite set, unit set, subset, power set, equal set. I mean, most of the types are being here. We will elaborate each and every type. And let us start with the first type, the universal set. Universal set is an all-inclusive set. That means a set containing everything. It's an all-inclusive set and usually represented by using the symbol omega. So we usually represent omega to elucidate the universal set. So universal set is an all-inclusive set. It's an original all-inclusive set is known as universal set. All other set are the subset of the universal set. We will explain what is the meaning of subset a bit later. So universal set is an original all-inclusive set. Everything is included in the universal set. As the name itself said, it's a universal. Everything is included. So original all-inclusive set is known as the universal set. For example, if I am writing a universal set of the students, that means all the students will be there in the universal set. So it can only be explained by using the method of description. Because you cannot write by using the method of enumeration, right? Okay, so universal set is an all-inclusive set and we usually represent it by putting the omega. It's an all-inclusive set. Now, exact opposite is the null set. Null set is nothing but an empty set. It's an empty set. That means a set containing no element is known as null set. And we usually represent it by using the symbol phi. Either phi or two brackets empty in which there is no element. So null set means an empty set. Null set means an empty set. A set containing no element is known as an empty set or null set. Clear? Okay. Finite set or finite set, what you want to call it. Finite set is a set containing countable number of elements. Or finite set are those sets that include or that incorporate finite number of elements. That's why finite set is also called the countable set. Countable or denumerable set. Denumerable means or numerically you can count how many numbers are there, how many elements are there. So finite set means a set containing finite number of elements. We call it finite number of or finite set. That means, so finite sets are always countable. Countable in the sense that you can count the elements of the finite set. So they are always countable, they are always denumerable. That is the finite set. Infinite set are, as the name itself suggests, it means it contains infinite number of elements. You cannot count how many numbers are there. They are non-denumerable set. These are non-denumerable. You cannot count how many numbers are there. Remember, we have put a set of integers, all positive integers. It is an example of infinite set, infinite set, because you cannot count how many positive integers are there. So when you cannot count, you cannot write in the form of enumeration. You can only write in the form of description. So infinite set can only be explained, only be written in the form of description. So infinite set are those sets whose numbers cannot be counted, whose elements cannot be counted. We don't know how many elements are there. So infinite set are non-denumerable set. Stars in the sky is an example of infinite set. Stars in the sky. We don't know exactly how many stars are there. So we call it as an example of infinite set or infinite set. Non-denumerable set and non-countable set. Now you have the fifth type is known as the unit set, sometimes also called a singleton set. A singleton set. Unit set means a set having only one element. For example, say I put like this, a set say S is equal to 6. This is a singleton set. Singleton set in the sense that this set consists only one element. So if a set is having only one element, it is known as the unit set or singleton set. So we have 5 types. Universal set is an all-inclusive set. Null set is a set having no elements. Finite set is a set having countable number of elements. Infinite set is a set whose elements cannot be counted. Unit set is only having one element. Now, let us explore a very important type of set which we called as the subset. Subset is very important because we will use the concept of subset extensively in our subsequent analysis. What is subset? Let me put an example like here. For example, say, let me put a set, say S equals say 6, 8, 10. And another set, say P equals 8, 10. See here, I have two sets here, and a set called S that consists of 3 elements, 6, 8, 10. Obviously, it's a finite set, right? And I have another set called P, which is 8, 10, 8, 10. Observe the similarity. That is, all the element of set P is there in the set S. So we can call it as P as a subset of set S. P as a subset of set S. Or let me put the name in a bit different way to explain it a bit later. For example, this is a set A, and let me put this as set B to make things a bit more clear. Set A consists of 3 elements, set B consists of 8, 10. Now we can say that B is a subset of A. Why? Because all the elements of B are there in the set A. A is a big set and B is a set that is constituted by using some of the elements of A. Right? Now let us explain the meaning of subset. Subset of A is another set B such that it consists some or all the elements of A. Once more. Subset of A is another set B such that it consists some or all the elements of A. So, if you constitute another set by using some elements or all the elements of A, it is known as the subset of A. So, that is the meaning of subset, and we usually write it in this way. This is how the subset is written. This is read as B is a subset of A. B is a subset of A, or B is contained in A. B is included in A. B is a subset of A. B is contained in A. B is included in A, or B is a subset of A. It should be remembered that a set is the subset of itself. That means one of the subset of A is A itself. Again, by definition, the null set. What was the null set? Null set is an empty set, right? Null set is a subset of all the set. So 2 points should be remembered. 1, the set itself is its own subset. 1, the null set by definition is a subset of all the set. So that is with respect to the subset. We will elaborate this concept in a very detailed manner when we explain the different kinds of set operation. So that is with respect to the subset. Now we have a power set. What is a power set? Power set of a set consists of all the subset of a set. Let me go like this. For example, the power set of say set A, it is written as like this. The power set of set A consists of all the subset of A. Let me put like this. For example, A equals, what was our number? 6, 8, 10. That was our example, right? Set A consists of 6, 8 and 10. Let me write the subset of A. Subset of A will be like, subset of A will be 1, 6, 8, 10, obviously, because that set itself will be its subset, comma, null set will obviously the subset of every set. Then I have one number 6, then 8, let me continue here, then 10, then 6, 8, then 6, 10, then 8, 10, 1, 2, 3, 4, 5, 6, 7, 8. Yes. all the subset of set A is being written here, right? We have 3 elements in the set A and I have 1, 2, 3, 4, 5, 6, 7, 8 subset. So all the subset of A is called the power set of A. In description, power set is usually written as like this. Power set of A is the set of all x such that x is a subset of A. X is a subset of A. So all the subset of A will form in the or will constitute the power set of A. So I have 3 elements and I have 8 subset. Now how to calculate that? We have an equation, we have a formula, right? If a set having say n elements, then the power set consists of, or it will have 2 raised to n subset. For example, if I have only 2 elements in a set, that means my set consists of only 2 elements, say 6, 8. Then how many subset I will have? 2 raised to 2, which is 4. If I have 3 elements, 2 raised to 3 is 8. I have 8 subset here. Then 2 raised to 4 is 16 and so on. That means so how to calculate the number of subset, or otherwise how many elements will be there in your power set, because power set means power set consists of all the subset of a set. So we can use the formula 2 raised to n, where n is the number of elements in the set. If I have 2 elements, it's 2 raised to 2, 4. If I have 3 elements, 2 raised to 3, as we saw, it was 8. So that is the power set. So power set consists of all the subset of a set. Now I have an equal set. Equal set, or what is an equal set? Equality of set. Equality of set means if the elements in the 2 sets are exactly the same, that 2 sets are called equal or equality is there. For example, say if set A is equal to say 5, 6, set B is also includes 5, 6, we can call it as A equals B. Simple. A equals B. That means both the elements of the both sets are exactly the same. We call it as equality of sets, where A will be a subset of B and B will be a subset of A and B. So like this, A is a subset of B and B is a subset of A and B are equal. We call it as equality of sets. One point to remember, there is another term, we call it as equivalent set. There's a slight difference. Equivalent set, equivalent set means if the number of elements in the 2 sets are equal. Like for example, say A equals 10, 20. B equals A, B. See here, elements are not the same, but the number of elements are the same. A includes 2 elements. B includes 2 elements. These are called the equivalent set. So there is a difference between equal set and equivalent set, just to clarify that. So we have how many types? We have 8 different kinds or different types of set. Once more, universal set is an all-inclusive set. Null set consists of no element, it's an empty set. Finite set means the number of elements are countable. If a set consists of finite number of elements, we call it as finite set. If a set consists of infinite number of elements, like for example stars in the sky, non-denumerable set, infinite number of elements, we call it as infinite set. A set having only one element, it's called singleton set or unit set. Subset of A is another set B such that it consists some or all the elements of A. You have a power set that consists of all the subset of a set. Equal set means if 2 sets are having exactly the same number of elements. Equivalent set means exactly the same elements. If they have exactly the same number of elements, we call it as equivalent set as well. I think most of the types or the kinds are being explained here. Now, we will end our discussion for the part 1 series of set theory today, and with this note, and hopefully we will continue our discussion in the next session by looking at the set operation. And before that we will elaborate the concept of Venn diagram, and we will see the important operation of the set, like union of the set, intersection of the set, difference, partition, as well as complements of a set. So that part, that means set operation, will be explained in the next segment. Hope that this entire new experience of mathematical tools are helpful to you. Please do comment for the modification that is needed. So until we meet next time, stay safe, happy learning. Thank you.